Good morning, everyone. I'm João Costa. I'm from Fraunhofer AICOS, and I'm here to present our work for the CLEF eHealth 2020 Task1 challenge pertaining clinical code extraction from textual data using fine-tuned BERT models. For a general quick overview, we performed two different methodologies using conditional random fields for identity recognition and using BERT for named entity recognition. The BERT architecture provided the best results for ICD-10 code extraction. For subtask 1, we got 4th place, subtask 2, we got 2nd place, and subtask 3, we got 4th place overall. These sort of pre-trained deep learning models for ICD-10 code extraction are promising and powerful. However, they need to be enriched with some sort of online knowledge bases to increase their performance. Now, we use mainly BERT, and BERT stands for bidirectional encoder representations from transformers, as you probably know. And it's a very popular Google NLP deep learning model that was released in 2018, and when it was released, it improved the state of the art of 11 different NLP tasks. There's two main steps to use this sort of deep learning model. First, we pre-train on a huge text corpora versus web crawls, Wikipedia, etc. And then we fine-tune for our particular data set and our particular task. And its code is freely available on GitHub, and it's also available on the Transformers Python package, which is the one we use to implement our models. Now, for a general overview of our methodology, we use BETO, the Spanish BERT model, and we perform a language model fine-tuning step to generate Dr. BETO, and from Dr. BETO we perform a named entity recognition fine-tuning to generate Dr. BETO D and Dr. BETO P. Now, as I've said, we use the Spanish version of BERT, in this case BETO, which is it's only pre-trained on Spanish text. We could also create our own Spanish BERT model, but we don't have the resources for that. Or we can use a pre-trained multilingual model, but that maybe could lead to a weaker performance. So we decided to use a Spanish version of BERT. Now, BETO is tuned for general purpose Spanish text, but clinical records have their own jargon and specificities. So we can perform language modeling on our training set to further tune BETO to our data set, in this case to better model clinical records and to have some more insight on their related terms, thus generating Dr. BETO. Now, from Dr. BETO, we perform a named entity recognition fine-tuning of the BERT model to generate two different models, Dr. BETO T, which is a named entity recognition BERT model that is only trained on the diagnosis codes, and Dr. BETO P, which is only trained on the procedure codes. And these codes are obtained from the train and dev datasets. Now, to make a prediction with these two models, we just need to have the text for a test report, and Dr. BETO D identifies the spans and tokens that are associated with a given ICD-10 D code, and Dr. BETO P does the same thing, but identifying procedure codes. For each test report on subtask 1, we just need to associate all identified D codes with the report and rank them. On subtask 2, we need to associate pretty much the same way the P codes with the report and rank them. And on subtask 3, we associate all the D and P codes as well as their spans with a given clinical record. As for our results, as I've said before, we've achieved the 4th place overall on the first subtask with D codes. On procedure codes, we got 2nd place, and on the 3rd subtask, we achieved an F1 score of 0.505, which means a 4th place overall. However, the model cannot identify every possible ICD-10 code. It can only predict codes that are present in the training data, which is a huge step back. And the P codes are harder to extract than D codes, probably because their information is more scattered across the text. To conclude, this is a difficult, but it's a very relevant challenge. For instance, ICD-10-11 will come into effect on January 2022, and these sort of starting approaches to the problem need further work, show promising results for the future, but will most likely require some sort of external knowledge base to correctly classify infrequent codes to further understand the relations between codes and text. We also need to model the hierarchical structure of ICD-10 codes, but these sort of deep learning approaches combined with extensive databases and large multiple corpora are probably the way to go. with, for instance, new NLP models that can process long sequences of text, such as BERT from Google as well. Thank you very much for your attention.